Hello guys, so here we are again with our series on design patterns. I know I left you waiting for a while, but I've had stuff to do, got busy with some other stuff, and then I installed Windows, and now I got also Visual Studio 2017. Anyhow, a lot of stuff going on, but I didn't forget about this series. I'm really interested in finishing it and finishing it as nicely and as usefully for you as possible. So, when I left you, we were talking about the Simple Factory Idiom, if you remember, which is not actually a pattern, but it's an idiom, and that means that it's not as complicated, as important as a pattern is, but it's still a useful practice and a trick that you'll see actually used maybe more often than the actual creational patterns. So today I want to talk about the factory method pattern, and the factory method pattern is probably the simplest creational pattern that we can discuss, the more straightforward, and here its definition. When we apply the factory method pattern, we define an interface for creating an object, but we let subclasses decide which class we want to instantiate, and the factory method lets a class defer instantiation to subclasses. So what this basically means is very simple, and we can clarify it further by looking at the UML diagram. As you see here, we have a class which we call the creator, which is a class that has actually not just the responsibility of creating the object, because we assume that this creation process, while still varies, it's not that important, not that complicated. So you see it has the factory method, which is the method that will be responsible for creating our objects, and it has also other operations. Here you can see one, but of course it could have many, and it will probably have many. But this class will usually not take the responsibility of implementing this factory method, and so to decide which object we want to create. What we mean by that? Well, we mean that actually, our products are part of a family. That is, we have an abstraction, which could be an abstract class or an interface as usual, and then we have one or more concrete products. Well, usually more, of course. Otherwise, why would we have an abstract class or an interface if we didn't have more than one implementation, or if we didn't leave the door open for more implementation? So the idea is that the creator class wants to be free to create many different implementations of this interface, or you could say many different subclasses of this product class. And so it will typically be an abstract class and leave this method abstract, or in a variant it could also be a concrete class, and it will actually give an implementation to this method, but it will be, let's say, a default implementation that subclasses will override. But more often this method will be completely abstract, and so the class will be abstract, and so the actual creator will be subclasses of the original creator class. And of course, each different concrete implementation of the creator class will return a different concrete product. And as usual, all this will become much more easy to understand when we see a little concrete example. We have already one class that we call food store, and this will play the role of our creator. So it will be this guy here, basically, the creator class. And we just finished to say that it will most often be an abstract class. So let's go back to food store and adjust that and say that this will be a public abstract class food store. And since we are creating food, because, well, of course, you know, that's one of my favorite interests, unfortunately, let's create some food. And as we saw in the UML diagram, we need to have, as you see here, an interface or an abstract class, and then various implementations. So let's go back to our Solution Explorer and say, okay, maybe we want a new class, and this new class will be some kind of food. Let's say it will be an arancino. Now, arancino is a very delicious little food item that you can taste if you go on vacation in Sicily, and I highly advise you do that. So this will be public class arancino, and as I said before, this could be an abstract class, it could be an interface. For now, let's just say it's an interface, just for the sake of simplicity, and say public interface arancino, and say it has just one method that's called taste. There we go, and then we'll have different implementation of this guy, of course. So again, we want to have another class, and this will be called arancino catanese, from the city of Catania in Sicily. And there we go. And this will be, of course, an implementation of arancino. And being an implementation of arancino, of course, we have to implement this interface, and we just like something like, I guess, console. These, of course, are all toy examples, so the pattern can really stand out and not to be distracted by useless noise. I am a very tasty arancino Catania style. There we go. So we have our arancino catanese, and as you can imagine, the other implementation will be very simple. I'm sure you know where I'm going here, and this will be arancino palermitano from the city of Palermo, another nice and important city in Sicily that you should most definitely visit. There we go. I think the Italian government should give me a sponsorship for advertising, for inviting people and doing advertisement for Sicily. Okay, so boom, console right line, arancino, Palermo style. There we go. So now we have our abstract product, the arancino, and our two implementations, the arancino palermitano and the arancino catanese. So I think it's time to go back to our food store. And let's say we have a few concrete methods here. For example, public void receive order, int how many, and this will do some stuff that we don't really care about, and another method that could be ship order, and we don't really care about this one as well. And you can see where I'm going, just a few methods, that this class is able to implement easily. But then we have the point where we actually need to create our food, so which for now is just one different variant of the arancino. So what this will be public method. What it will be return? An arancino catanese or an arancino palermitano? Well, actually, it will return the abstraction, the interface. So it will return this guy here, return just arancino, and we can call it, of course, cook arancino. And what will this method do? We don't know, because at this point the class food store doesn't want the responsibility of choosing if she wants to return, she wants to cook arancini catanesi or if she wants to return arancini palermitani. So what this method will do is just throw his hand in the air, say, okay, I'm an abstract method, because I'm sitting in an abstract class anyways, and it will be the subclasses that will decide which kind of arancino is going to be cooked. So let's say this is a chain of food stores all around Sicily. If the shop is in Catania, we will do arancini Catania style, while if the shop is sitting in Palermo, of course it will do arancini Palermitan style. So we have our family of products. We have our abstract class which can handle, receive orders, handle products, and it's also a declaration for an abstract method that will actually create the arancini. What are we missing? We are missing the different subclasses of the creator class that will cook the different kind of arancini. So let's go back to our Solution Explorer and say, all right, let's have another class. And this will be a Palermitan style food store, for example. So it will be Palermo food store. There we go. And let's make it public. Let's make it extend our food store. And of course, the compiler is not happy because it says, okay, if you don't want to be an abstract class, you actually have to implement the abstract method. Here we go. And here, very simply, we will just return our arancino palermitano. And I think I can actually do this even better. Let's say new arancino palermitano, and boom. And there we go. Actually, there we go, not really, because I think we have forgotten to do something important, and that is to say that this guy is implementing our interface arancino. Whoops, sorry for that. I'm leaving this in the recording, just to show you that I'm doing this live. And nobody's perfect. We all make little mistakes. The important thing is that we know what's going on when there's a mistake, and we know how to correct it. You don't have to be perfect, remember everything and never make a mistake to be a programmer, which is good news, because otherwise I should definitely find another job. So let's go back to our Palermitan food store. There we go. So now we have our method that returns the arancino palermitano. So let's go and create the other food store from Catania, otherwise the guys from Catania will be very angry at me. I know there's, we Italians are always fighting among us. Let's call it Catania food store. And let's make the class public, as you know. Here goes the implementation of the food store, and here comes the implementation of our abstract method. There we go. And this will be new arancino catanese. So we are all happy. Actually, to be honest, I never tried arancini palermitano. I've just tried the Catanese ones, which were delicious, and I'm sure the Palermitan one will be as good. Anyways, I don't want to bore you with my food tasties, which of course you don't really care about. And now I think it's time to try this out, and instead of just writing code in a main method, I think I'll just add the unit test project to this solution, since that was the path that I was taking in my last videos on the Simple Factory Idiom. So let's go and add a new project, and I will use XUnit just because it's cooler. It's unit test project, C#, and I think we can call it design pattern examples test. Seems like a reasonable name. There we go. And I think we want to rename this something like food store test, I guess. Or yes. And I think we want to call this something like I guess cook arancino Catanese. So what we need, well, actually we need to give to this project, to the test project, a reference to the design pattern project. So let's do this right away. There we go. And then we can reference our food store. And of course we have to import its namespace and say food store equals new, and let's test a new food store from Catania. Let's see what the name was. Catania food store. There we go. And then we say arancino. Whoops, sorry. Sometimes Visual Studio tries to be a little bit too helpful. No, not new, because we are using our store to create it. And so we'll say store.cook arancino. There we go. And now we'll make an assert, and what do we expect? We expect this that this object that here is pointed through a reference of the interface arancino is actually of class arancino catanese, and we can do this easily, saying assert is type of arancino catanese. And test my little Chino object. There we go. And if we build our project, and if you open the test explorer, we should see our test listed here, and we can run it and check that it passes. There we go. And I think that you know what I'm going to do. I'm just trying another one, and I'm just checking that also the Palermitan the Palermitan version will work. So this time we'll do Palermo for store, and then store.cookarancino. And then let's just leave this as it is now, just to check that this test will fail, because now I'm using the Palermo food store, so my little Chino is actually a Palermitan arancino, but let's check it. And yes, it has failed. Why it has failed? Because we have to change this to arancino palermitano. Oops, sorry. There we go. And finally, we can run all our tests and be sure that they will actually finally pass. There we go. So now I know I've taken quite a few time to explain this simple pattern, but I just wanted to make sure that the idea got through easily and nicely. And you know, I'm still quite new at doing video tutorials, so my tempo is still pretty much that of a live lesson. But just pretend you're hanging out with me live and sitting around with me and just discussing about design patterns. I think even if you take a few minutes more, it won't hurt. And you can always watch this as at a faster speed, because I know, it's not, video tutorials should be a little bit more concise, because they're not as lively as a live lesson. But anyhow, I know you could be thinking, okay, Riccardo, I think I got this. Now, the concrete type of the arancino is hidden by this call to the factory method, that's cook arancino, here and here. So it's completely transparent to my code what kind of concrete product I'm working with, and then I can just interact with these products through polymorphism and method override, and my code is more general because it doesn't have to worry about all the difference between the different products. In this case, I don't have to worry about if I'm going to taste some arancino catanese or an arancino palermitano. And that's good, but you could object, okay, Riccardo, you have hidden this, but then we have another problem. How about this? You have hidden the new of the arancino, but we still have to do the new of the food store. So before we had the problem that we wanted to hide the explicit call to the constructor of the product. But now you have the problem that you actually have an explicit call to the constructor of the concrete producer. So let me go back to the UML diagram for a second. And so now we can be very general on the products, but we are forced at some point to instantiate one concrete creator, and at that point you have to make a choice, and you could say, so isn't it the same stuff? Haven't you just postponed the problem and moved from the product to the creator? And yes, in a way I did, but there's a difference, and the difference is that I expect in my application to be needing a lot of products, so to have to invoke the factory method a lot of times and instantiating a lot of products, but I do not expect to have to create a lot of creators. So the call to the concrete creator will be much less and much more controllable than the calls that I would have to do every time I want to create a product. They won't be littered around all over my application. And of course I can choose which concrete creator I want to use with very flexible method, like reading a string in a configuration file, or even doing reflection on the current assembly and looking for the available implementation of this interface or the extension of this abstract class creator. To sum it up, this is a very simple pattern, even if it taken quite a long time to explain it. Once we really understand this factory method pattern, we can see that it's actually very simple. So that's why I'm saying that design patterns are far from being rocket science. It's basically just subclassing or implementing an interface and doing one method override. In this case, the method is just a little bit special because it's the method that's in charge of creating a family of product. But the concept is very simple. It is just the typical thing that we do to respect the open-close principle, This principle says that our code should be open for extension but closed for modification, and that means that I want to be able to instantiate different kind of products without modifying code that already exists. So my code should be open for extension but closed to modification. And the easiest way to do this with an object-oriented language like C# is through polymorphism. This is just polymorphism on the concrete creator. Our application will think about in terms of the creator and product, and then I can choose a concrete creator and work with concrete product. It is just polymorphism in action in the case of a method that wants to create other object. And that's all for the factory method design pattern.